Okay, so we can look for the formula of the transformation so we're taking the function f and we're transforming it to the function g. So one thing we can look at is that the function f has a minimum at -1 and a maximum at 1, and the function g has a minimum at -4 and a maximum at 4. So we know that there is a vertical stretch by a factor of 4. And horizontally, this goes from 0 to 8, but this one goes from 0 to 4. So there is a horizontal shrink by a factor of 1/2. Okay, and so then to do that vertical stretch, I'll have g of x is equal to 4 f of x. And then, well, actually, not f of x. So to account for the 1/2 horizontal shrink, we're going to do we'll do 2 here, 2x. So the horizontal shrink is 1 over that b. So it's 1 over 2, so the 2 goes there. Okay, the average rate of change of f over the interval from 0 to 1 is 4. Okay, so that means that this function from 0 to 1 has an average rate of change of 4. So it's going to go up 4 units each time you go over a 1. Give the average rate of change of f over the interval for each of the following transformations. Okay, so for this one, -2 f of x, well, I don't know why I put the axis there. So the axis goes here. Okay, so, all right. So if it's -2 f of x, then what that's going to do is it's going to flip it over the axis, and it's going to stretch it by a factor of 2. So then that would be a slope of -8. Because I'm multiplying that rate of change by -4. Okay, and then here, my average rate of change is 4, but then I want to do this transformation where I multiply that by 1/3. So that's just going to shrink it by a factor of 1/3. So the slope of that is going to be 4/3. Okay, then determine whether the function is even, odd, or neither. So I want to look at f of -x. So that's the square root of -x squared plus 1. Well, when I square a -x, that just makes it the same as x squared. So and that's equal to f of x. So since f of -x equals f of x, then the function is even. An even function f is decreasing in concave down in the first quadrant. What can you say about that function's behavior in the second quadrant? So if I think about this function, it's an even function. It's decreasing in concave down, so something like this maybe in the first quadrant. What can you say about the function's behavior in the second quadrant? So over here, it needs to be, if it's even, then it is mirrored about this axis. So if it's mirrored about that axis, then it will be like this. So it should be increasing in concave down. Okay, because it's just going to be like the mirror image of that in the other quadrant. Okay, number 22, without using a calculator, rank the following in order from smallest to largest. Okay, so let's think about our unit circle here and what we have. Okay, so I have 12 degrees, so that'll be kind of a small angle here. So I want to do the cosine of 12 degrees, so that'll be the x coordinate of that. So that's this length here. Cosine of 85. So for 85 degrees, that'll be really close to 90, right? And I want to look for the x coordinate of that, so that's this one, okay? And then cosine of 165, that'll be like out here somewhere. And so I'm going to look at the x component of that, that's a -1. Cosine of 180 is actually -1. So if I'm at 180 degrees, that's here, that's this x coordinate, so that's actually -1. So that's going to be the smallest one. Cosine of 265, so that'll be really close to 270, so that'll be like right here. So that's this value here. And then cosine of 350, so 350 will be over here, almost 360, and so it should be this one. Okay, so that's going to be the biggest one. So cosine 180, then cosine 165, so that's here, this distance, this negative distance. Then we'll have cosine of 265, wait, yeah. Okay, and then let's do the positive ones. That green one was cosine 85. I should color code this. Yeah, let's make this color coded. Okay, and then those two are yellow. Okay, hang on. What's the cosine 265? That's this black one. Oh, dang. That's this one here. Okay, and then cosine 85, and then we have cosine of 12 degrees, and then cosine of 350. Okay. Find all the angles between 0 and 360 that have the same cosine as 230 degrees. So I'll draw that on my unit circle. So 230 degrees will be over here in this quadrant, right? And the reference angle is going to be what? So if I did 230 minus 180, I would get that reference angle there is 50. Okay, and so if it has, this is the cosine value of that, is the x coordinate. And so I need to go up here to the reference angle 50 to see what that angle is. So if I did 180 minus 50, that gives me 130. Okay, and then I want the same sine value as 305. So let's do that one. So 305 will be over here somewhere. And so the sine value is the y coordinate of that. The reference angle for that is 360 minus 305. So it's 55 degrees is the reference angle. So I need something here in the fourth quadrant with that same reference angle. And it will have the same y coordinate. Okay, so what is that? So if I do 180 plus 55, that gives me 235. So that's my answer here. Okay, find 4 positive angles in different quadrants with the same reference angle as -105. Okay, so let's think about this. So if I go -105, that's going to be past 90 to past -90, so that's over here. And so let's figure out its reference angle. So if I did 180 minus 105, that gives me a reference angle of 75 degrees. Okay, and so, so I can just draw all of those 75-degree reference angles. So in quadrant 1, that's going to be 75 degrees. In quadrant 2, it's going to be 180 minus 75, gives me 105. And in quadrant 3, it's going to be 180 plus 75. So that gives me 255. And then in quadrant 4, it's going to be 360 minus 75 gives me 285. Because this is 75. All right, and then name 3 angles that are coterminal to negative 40. Then name 3 angles that have the same reference angle but are not coterminal. So we have negative 40, that's down here somewhere. So if I did 360 plus negative 40, that gives me 320 degrees. That would be going this direction. So I need to name 3 angles that are coterminal. So 320 degrees is coterminal. I could go around 2 times. If I go around twice, then I could do 320 plus 360, and I would get 680 degrees. I could also go backwards and go around all the way and then the negative 40. So I could do negative 40 minus 360, and that gives me negative 400. So those are some examples. So I could generate more by adding and subtracting 360, multiples of 360. Now I want to name 3 angles that have the same reference angle as negative 40 but are not coterminal. So let's find some. So these are coterminal. And then this is the one with the reference angle. So this angle here, which is 40 degrees, this angle here, which is 180 minus 40, which is 140, this angle here, which is 180 plus 40, which is 220. So, so 40 degrees, 140, and 220 have the same reference angle. Okay, assume angle A passes through point A and angle B passes through point C. Okay, gotcha. Which value is the smallest? Okay, so for the sine value, sine is the y component. So I just want to look for the one, if I'm looking across, you know, like this, I just want to see the one that has the smallest y value. So that would be this one down here. Sine of E would be the smallest because, sorry, I don't know if those lines made sense. Because if I look at the angle E, the y component would be the largest negative number. So it's closest to -1. So sine of E is the smallest. Which value is the largest? So the largest one will have the largest y value. So it's a little bit hard to tell, but I think sine of A is slightly higher than sine of B. So sine of A is going to be the largest one. And now we're looking at the cosine of these. So which one is the smallest? The cosine will be the smallest when this angle here has the smallest x component. So it will be cosine of C will be the smallest. And then which value is the largest? That'll have the largest x component. So cosine of F is the largest because it's the positive x value, the biggest positive x value. All right, so the last problem is this one. It says find the coordinates of a point on a circle of radius 5.8 centimeters at an angle of 200 degrees. in standard position. Centered at the origin. And there's a picture that goes along with this. And the picture looks like this. You have this 200-degree angle. And you have a circle. And we're looking at this point right here, the coordinates of that point, P. And so the first thing we might want to notice is that the x-coordinate of this point P is going to be negative, and the y-coordinate is also going to be negative. So we can expect that the two points that we have will both be negative, okay? And then the other thing is that we know that the x is going to be r cosine theta, and the y is going to be r sine theta. So we can go ahead and plug in those values. So that the radius there is 5.8. Oh, and the theta we can plug into. The theta is 200. Okay, and when I plug these into my calculator, I want to make sure that I am in radian mode. So if you go to your calculator, make sure you change it to, sorry, not radian mode, I want to be in degree mode because that angle is measured in degrees. So I'm going to change it to degree mode. So I'll do 5.8 cosine of 200, and that gives me negative 5.45, let's see, round to 2 decimals. So negative 5.45, and for the y, it'll be 5.8 sine of 200, and that's negative 1.98. And if I look at the picture, it looks like that seems to make sense because the x-coordinate is negative 5.45, so the x-coordinate is like a longer distance, right, than the y. The y is negative 1.98. So, so that's the answer to number 27. So that's the end of this exam review.